Sonic, the heart of your system.
Hi and welcome to a new video here on my channel. In today's video we will talk about the Xeon 4110, which is a workstation Xeon. I think it has 10 cores, it has a base clock of 2.1 GHz and turbo clock of 3 GHz. We will use this CPU to test if it's soldered or not, because you all know that I already deleted and tested the 3175, the unlocked 28 core Xeon, and we all know that it has conventional thermal paste underneath. But there is a German price comparison website where you can check different CPUs, and they also list if they're soldered or not. Most of the time they are correct with their information, but I saw that on this CPU they list that it's soldered, and I would actually be very surprised if they would solder those CPUs but not the 28 core Xeon, because it's all the same production line in the end. It's all still Skylake X, which we know all of those previous Skylake X like 7820X, 7900X, 7920X and all of those, they have not been soldered. So I would be surprised if the CPU is soldered. We will try it using the Delid Die Mate workstation, which I launched actually last week. I didn't do a video about it yet. That's basically what this video is also for, so I can show the Delid Die Mate WS the first time. So it's basically just the same as the one you've already seen on my channel. It's just a bit more advanced, looks obviously a lot better. So has anodized aluminum black. We have a different mechanism. So basically this screw is pushing out this slider, and the slider is also attached to something that's keeping the slider back in place. So it's a lot more convenient than the prototype which I originally showed. So going back to the Xeon 4110, that's the CPU we will try to delete today, and we will use it on the WS board from Asus. It's the C621E Sage workstation board. We will use it in combination with this Noctua cooler. It's an NH14S. And the thing is, I originally wanted to use an EK block to simulate like water cooling, which you typically don't use in server solutions, but then I figured out that I cannot mount my EK block on there. Actually, there are two different EK blocks for two different sockets, because the socket 3647 seems to have two different mountings. So we have like a narrow mounting and a wide mounting, and I think the Dominos Extreme is using the narrow mounting. And then I figured out I don't have the correct EK block. That's why I went for the Noctua air cooler instead. And inside the Noctua air cooler accessories, we also have those two mounting plates. So they are basically for the narrow socket and the normal socket. And that's what you put, or basically you clip your CPU inside this frame, and then you can mount the CPU on the cooler and then mount the cooler with the CPU inside the socket. And there's also written on this piece of plastic that it's TIM breaker, which I assume means that it's a thermal interface material breaker. So maybe this keeps the CPU in place once you remove the CPU cooler, so you don't have the CPU stuck on there, which is something I really disliked when I was testing the Dominos for the first time, because mainly if you use it with a water cooler you don't have this, and that's something I was really not a fan of. So for now, first thing to do is mount the CPU on this air cooler, or attach all the accessories on the air cooler, and then mount the air cooler on the board and check what the CPU looks like. System is set up and we're currently testing Cinebench R20, and the temperatures are extremely good. We're hitting 40, maximum 41 degrees Celsius. I tried to see what we can get out of the CPU maximum. So I entered the BIOS of the mainboard, and there's not much we can do. We can only lock the CPU to the highest maximum multiplier available, which is 24 in this case for multi-threading. The CPU can boost up to 30 with a single core, but for multi-threading it's just 24. So I enabled this option to always lock the CPU at 24. So we can get the maximum multi-threading performance out of the CPU. It's only running at 0.8 volt. That also explains why the CPU is so extremely cold. The cooler is locked at 500 RPM max. So it's really, you cannot even hear it, and still it's not exceeding 40 degrees Celsius. So it's extremely cold, which could be an indicator that the CPU is soldered, or that the power consumption is just extremely low, which makes kind of sense. It's 8-core, 24 multiplier, 0.8 volts, so the power consumption is really not much. In the next step, I will take the CPU out of the socket, see what we can do with it, see if we can delete it, especially if it's soldered, it could be a problem. There are also some smaller ICs next to the chip, which could be a problem for deleting. We will just see how it goes if we remove them, hopefully not. If we take a look at the performance, it's 2,527 points in R20, which is just above the 7700K. So multi-threading performance-wise, quite impressive, I would say. Also taking into account how cold the CPU is, also power consumption should be very, very low. So let's take the CPU out of the socket. Just remove the CPU from the socket, and it's really, really convenient with this small plastic adapter, and I'm always fascinated about the cooler quality from Noctua. It's just really, really nice work. And we will now try to delete this CPU, and I noticed that there are some smaller ICs underneath here and here. I'm not sure if you can see it from the side looking through here. That could be a problem. Once we delete it, it could be that if we move the IHS to the side that we are removing them. I will try not to do it, but we'll just see how it goes. Oh, CPU ist geköpft. As you can see, the German price comparison website was wrong. The CPU was not soldered. There is conventional thermal paste underneath. It's still impressive that the CPU is running so cold, but that's mainly probably because of the low power consumption. What's also very impressive is the surface area they use to glue the IHS onto the PCB. It's just so much bigger than on a conventional desktop CPU, and also bigger than on the 28-core Xeon. Then on the 28-core, this was actually smaller, the surface area on here. So just looking at the surface area here, and also on the top PCB, it explains why we needed so much force to remove the IHS. I actually had to use an extension on the Allen key to remove the IHS, but then it worked out fine. Also, all the components are still in place, so the small two ICs you can see here and here, the RFID chips, should still be fine. They're not loose, they're still in place. All the small capacitors are still in place. So I think everything should be fine. The next step would be to remove the glue. A lot of people always ask why there's like a stacked PCB design. That's very common on those very big PCBs. It's just electrically a lot easier to design the top PCB first and then have the bottom PCB spread out all the traces to the socket. It's just easier and cheaper for manufacturing. That's the only reason. It's not like this is a different CPU they use for a different socket. That's not the case. So next step, clean everything, put on liquid metal and see what we can get temperature different wise. CPU is back in the socket, everything worked out fine. I already performed another Cinebench run. Performance is obviously still the same because CPU is still clocking to 2.4 GHz across all the 8 cores. And you can see in core temp, the maximum core temperature was 36 or 37 degrees Celsius. So on average, I would say something like 5 degrees Celsius improvement over the conventional thermal paste, which is kind of more than I expected looking at the power consumption of the CPU and also the clocks. If you would probably apply this to a Xeon that has a higher TDP, higher clocks, I think the temperature difference should be the same like on a Skylake X, probably 10 to 15 degrees Celsius improvement. If you're looking at a, I don't know, 160, 200 watt TDP Xeon, then probably the improvement is a lot bigger than on this, but I didn't want to spend like 2,000 or 3,000 euro just to check if this is soldered or not. Now we know that all those Xeon 3647 Skylake X based CPUs are also not soldered, they're using conventional TIM. So if you're using, I don't know, some of them in server farms or whatever, and you're looking to delete those CPUs or improve your thermals, this could be something you can look into. By the way, this video was filmed with a new camera lens, and just give me some feedback if you noticed some improvements over image quality in this video, or if you have any kind of feedback about the video quality in general. I would just like to know if you noticed something, if you like it or not. Let me know what you think about deleting CPUs like this, especially considering that it's a Xeon that you probably want to keep it stock for warranty reasons or everything. Let me know what you think about this topic in general. See you soon. Took us so much force to remove this oops.